Hello, in today's video we're going to be starting section 10.8, which is on systems of nonlinear equations. So for example, we are going to still have two or more equations, but one of them, or maybe all of them, are going to be nonlinear. So in this example, I have a circle, x squared plus y squared is 25, and a line 3x minus y is equal to 10. When solving a system of equations, regardless of whether your equations are linear or nonlinear, we are looking for the points. There may be one, there may be many, of intersection of all graphs. So for example, the system of equations that I have given you here is a circle and a line, and we can see the two graphs, the red being the first, the circle, and the blue being the second equation, the line. The two graphs intersect in two places. So one of my solutions will be here at approximately 4 and just below 3. And I will also have a solution here at about 2 and a little bit less than -5. So what we are going to be doing is solving a system of equations to find the exact values of those points of intersection. Our first method is going to be by graphing. However, as we saw in that last one, it's a little bit hard to be fairly precise when we're graphing. Second method is substitution. And our third method is elimination. Today I'm going to focus on substitution, and then in our next video we'll focus on elimination. So to find the solution to the system of equations, in order to use substitution, I need to isolate one of my variables. So the easiest way to do that is to isolate, I think, the y in this first equation. So subtracting my 3x, 3x minus y is equal to 10. I'm going to start by subtracting 3x from both sides. I have negative y is equal to negative 3x plus 10. And then I'm dividing everything by a -1 to isolate that y completely. So y is equal to 3x minus 10. Now I can go to my other equation and replace y with that value. So x squared plus y squared is equal to 100. But y is 3x minus 10, and now I solve. So x squared, and then multiplying this out, I get 9x squared minus 60x plus 100 is equal to 100. And I can subtract that 100 over. And I will also combine like terms on the left to get 10x squared minus 60x is equal to 0. And now I factor nicely here. I only need to take out a GCF, which is 10x, leaving me with x minus 6 is equal to 0. So 10x is equal to 0, or x minus 6 is equal to 0. So I've got an x value of 0 or an x value of 6 as my possible points of intersection. Now in order to solve all the way, I need to make sure that I solve for y. So if x is equal to 0, then y is equal to 3 times 0 minus 10. And all I'm doing is I'm using my isolated y equation, which means that y is -10. So one of my solutions is 0, -10. If x equals 6, then I have y equals 3 times 6 minus 10. Y equals 18 minus 10, which means that y is equal to 8. So my second point of intersection is 6, 8. So it looks like my equations cross in two places, and that would make sense because in this system I do have a circle and a line. So what I'm looking at is a circle and a line that crosses through that circle, and it looks like we have 2 points of intersection, 0, -10, and 6, 8. Alright, go ahead and try this next one on your own after pausing the video. I'll isolate y by adding x to both sides. So y is equal to 0 plus x, or just x. And now I can go ahead and plug that in for my y value. So x squared plus y squared is equal to 32. So I replace x where my y should go, and then I just have 2x squareds equals 32, dividing by 2 on both sides. X squared is 16, which means that x is either positive or negative 4. Then I go back and I use my equation where y is already isolated to solve for y. So if x equals positive 4, then y is equal to x, which means that y is positive 4, giving me the point 4, 4. If x is negative 4, we know that y is equal to x, which means that y has to be a negative 4. So I have the point negative 4, negative 4. So my two solutions are 4, 4, and negative 4, negative 4. Last one, go ahead and pause the video one more time and practice this on your own. I'm going to go ahead and isolate my y in this first equation. So I've got x squared minus y is equal to 1. I'm going to subtract my x squared from both sides, giving me negative y is equal to 1 minus x squared, dividing everything by a negative 1. Y is equal to negative 1 plus x squared, and then I go back and I plug that in. So I know that I have 2x squared plus 3y is equal to 17, but I know that I'm going to be replacing that y with what I know that it equals, which is negative 1 plus x squared, and then I distribute and solve. And x is either a positive or a negative 2. So then I go back and I use my equation where y is already isolated to help me solve for y. So x is equal to positive 2 gives me y equals negative 1 plus x squared, but x is 2, so y is going to be 3, giving me one solution of 2, 3. Then I have x could be a negative 2, and y is equal to negative 1 plus x squared, so y is equal to negative 1 plus negative 2 squared. Y is equal to a positive 3 as well. So I have the solution negative 2 and 3. So our 2 points where these two graphs cross are 2, 3 and negative 2, 3. That brings us to the end of our video today. We're going to pick up in our next video for 10.8 discussing solving nonlinear systems of equations by using the elimination method. Thanks so much for watching and have a great day.